One might say that today is a great day. Because it's St. Patrick's Day. All things are in. So, if you didn't take a test yesterday, please get that done before you leave today. So we're gonna do one example today, and then I'm gonna give you a worksheet to work on with vectors, magnitude, direction, and all that stuff. Okay. So before we get to our one example, let's just get a quick general recap of the vectors. If you haven't filled out all the way to, so basically, if you had Roth on, I want to say Wednesday. Yes, Wednesday. If you had Roth on Wednesday, you didn't get the very last example. If you had me or Mrs. Hill and you started watching the video goes through that last example about a unit vector. So if you don't have that part of your notes filled in, go on to Canvas, Chapter 6 or Section 6.1-4.8. It's goofy, I know, but there's some other stuff that we're getting into with vectors from Chapter 4. Go on that video, fast forward it to the end, because it's like the last 5 minutes of the video, and the video is like 35 minutes long. Fast forward it right to the end and pick up that unit vector stuff. It is not that hard, really. Okay, it's really not that hard, but you can watch the video for that. Okay, but right below that, there should be a box on your paper that says "in general." Okay, so in general, we've got vector v has a component form. The horizontal component is x. The vertical component is y. That gives us our direction. That gives us our magnitude. Remember, magnitude is length. Okay? So x then is going to be the magnitude of v times the cosine of v's direction angle. Okay? So how far out you go, at what general direction you go, at what angle you go out. The y value then is going to be the magnitude of v times the sine of its direction. Now, where we come up with those, the magnitude of v is going to be, if we were to make it be a right triangle, it would be the square root of x squared plus y squared. Old school distance formula. Okay, so if you're given 2 points, you're given the coordinates of the head and the coordinates of the tail, you first have to find that vector by subtracting the head minus tail, and that gives you the vector in component form. Then from there, you can go there. So it's a simplified distance formula. Okay? And then the reference angle for it is going to be the inverse tangent of y divided by x, where once again, we drop any and all negative signs. Okay? Some things you just smile at. I have no idea what they're doing. There's some things you just don't fight about, you know? So anyways, so we got that. But then remember that because we're dealing with a reference angle, that then we're going to have to adjust into our quadrants. So if our angle is in quadrant 1, then our theta, our actual theta, is our reference angle. If we are in quadrant 2, our actual theta is 180 degrees minus our reference angle. If we're in quadrant 3, our actual theta is 180 degrees plus our reference angle. And if we are in quadrant 4, our reference, or 360 degrees minus our reference angle. And that goes all the way back to when we first did this. Okay? So with that being said, then let's do our one example. I don't know if this one is in your note packet or not. Is it number 10? Perfect. It is number 10 on the next page. Okay? So if the magnitude of u is 35, the direction angle of u is 25 degrees, the magnitude of v is 50, and the direction angle of v is 120 degrees, we need to find u plus v in component form. We're going to do that first. Then find the magnitude of u plus v. Then find the direction angle. Okay? Right? Well, vector u is going to be 35 times the cosine of 25 degrees, comma, 35 times the sine of 25 degrees. Now, it might be helpful for you to have a calculator, a scientific type one where you can do angles and sines and cosines, and inverse tangents and all that fun stuff. 35 cosine 25 gets me, we'll call it 31.72. Sine of 25, we'll call it 14.79. Agree on both of those accounts? Awesome. Why do I gotta throw stuff? Then we've got angle V, or excuse me, not angle V, vector V would be the vector 50 cosine 120, 50 sine 120. Agree with that? So then our vector u plus v would be the vector. I'm going to add those two together. Well, that one's pretty easy. That one's just going to be 6.72. Then I'm going to add these two together, and that's going to be what? 58.09? The hardest part of vectors is it's not a set of parentheses. You want, because you've been ingrained for so long to do points. X comma y is a point. You put parentheses around it. It's those crazy like alligator mouths. Okay, with me? Everybody agree with me on that? Okay. Then we need to find the magnitude of v. Well, the magnitude of u plus v is going to be 6.72 squared plus 58.09 squared, and then take the square root of that. So 6.72 plus the magnitude here is 58 point, we'll call it 48. Anybody back me up on that? Yeah? Yeah? All good in said hood? Yeah? Then, actually I probably wouldn't need to. Then we need to find the direction angle. So the direction angle is going to be, I'm going to have a reference angle, even though, actually no, I won't have a reference angle because which quadrant am I in? I'm in quadrant 1 because it's positive, positive. So I don't have a reference angle. I can go right to my theta. Inverse tangent of 58.09 divided by 6.72. Inverse tangent 58.09 gets me, I get a reference angle here of, or actually, excuse me, an actual theta angle of 83.40 degrees. And since we're in quadrant 1, that's what it is. All agree? And in our brains, we can kind of think that that angle has got to be closer to 90 because our horizontal component is only like 6, but our vertical component is like 58. So we're almost going straight up. Yep. Okay. So I have a worksheet for you. I just have to pass it out now, but that's what we're going to work on.